We're going to continue solving equations with radicals in them. If you saw the last video, if you have one radical in the problem, you need to get it by itself before getting rid of it by squaring or cubing or whatever to both sides. If you have two radicals now, you need to make sure that they're on separate sides of the equal sign. For this example, there's one on the left and one on the right. So now we can go to the next step of trying to get rid of our square roots. It was a square root, which means we want to square both sides. Those will cancel. Now on the right side, if you remember from the last video, when we had two terms that were being squared, we needed to FOIL. Well, here we have two terms that are being squared. So we're going to need to FOIL that. And our foiling is going to be a little bit harder here because we have radicals that are involved in our parentheses. Square root of x plus 2 times square root of x plus 2 is square root of x plus 2 squared, which just cancels. So we're left with x plus 2 for the first term. Then square root of x plus 2 times negative 1 is negative 1 square root of x plus 2. And negative 1 times square root of x plus 2 is negative square root of x plus 2. And then negative 1 times negative 1 is positive 1. Just like negative 1x minus 1x is negative 2x, negative 1 square root of x plus 2 minus 1 square root of x plus 2 is minus 2 square root x plus 2. So we can combine those together. And then let's combine all other like terms. And this is like a problem that we saw in the last video where we only have one radical in the problem. So we want to get it by itself so that we can get rid of it. We can subtract x from both sides. 2 plus 1 is 3. Be careful, we can't combine the 3 minus 2 because that's just like if we had a 3 minus 2x. Those aren't like terms, we can't combine them. But we can subtract 3 from both sides. Remember, we want to get the square root completely by itself, so we can divide both sides by negative 2. Now the square root's by itself, so we can square both sides to get rid of it. So x equals 14. Then, because it was square roots, we need to check our answer and make sure that it works. So we have the square root of 14 minus 5. Does that equal the square root of 14 plus 2 minus 1? So yes, it does work, which means 14 is our answer. The next problem, remember if you have a fraction exponent like this, it's just like you have radicals. So we have two radicals in the problem, which means before trying to get rid of it, we need them both on separate sides. If we don't get them on separate sides first, what we're gonna have to do is cube both sides. And because there's two terms here, we would have to FOIL that with 3 different quantities. So we don't wanna have to do that. Let's bring this term over. Remember, if it's a fraction exponent, take the reciprocal to both sides. So that's to the 3 over 1 power, and we can solve for x from there. Remember, another way of thinking of the 1/3 power is cube root, and cubed cancel, and x equals 15. Because this is an odd root, if you look at the denominator, it's a cube root, we don't need to check our answer because it's always gonna work. But if you wanna just get in that habit of always checking so you remember, then that's fine too.